So for this is the lab for title lab activity states of matter. And we are going to be looking on it should be page 21 in your packet. So we want to go over the guiding question first. So how does state change relate to temperature or change of state? How does that relate to temperature? So we've been talking about that for a couple days now. And our purpose in here is to determine the relationship between state change and temperature through the creation of a heating curve. So we, in your assignment from yesterday, you should have learned about what a heating curve kind of looks like and how they're formed. So in the introduction here, the law of conservation of energy, also known as the first law of thermodynamics, states that energy can never be created or destroyed, it only changes form. This sounds vaguely familiar because we have another law called the law of conservation of mass that also has some similar tones to that, but they're technically two different laws. We'll kind of research this law a little bit further later in the year, but basically what it says is that the energy that's put in to this through thermal energy is then transferred to the water through kinetic energy. So remember, kinetic energy is the energy of movement. Substances can change form or state by absorbing or releasing energy. So absorbing or releasing energy. Absorbing energy would be heating it, and releasing it would have to be cooling it or removing the heat of some way. So water is a substance that we've seen in all its forms, solid, liquid, and gas. Today we're going to observe solid water, aka ice, as it absorbs heat or energy and changes states. So we're going to observe it in all three states: solid, liquid, and gas. So the hypothesis here, in order to help form our hypothesis, we want this information in italics. So temperature is the average kinetic energy of all the particles in an object. So kinetic energy is the energy of movement and how fast are things moving. And the higher they're moving, the more temperature they have. So considering this, make a prediction about what you believe will happen to the energy of the particles, aka water, and the water's state of matter, aka is it a solid, liquid, gas, as the temperature goes up. So this one does not have to necessarily be an if, then, because statement. I simply just want a prediction here. So what do you think is going to happen to the energy of the particles, all right, of water? Think about them on a molecular level, all right, as little circles. What is going to happen to them as water changes its state of matter as we add heat and increase temperature? All right, so again, how does increasing the temperature affect the energy of the particles in various states of matter? Is the energy of the particles also increasing? Is the energy of the particles decreasing? Does it depend on the state of matter? Does it go up and down? Does it not change at all? So again, energy of the particles. Think about what those little molecules are doing on a molecular level. So pause the video here so you can create a prediction and tell me what you think the molecules are doing as they move through states of matter. Okay, so for the procedure, we're basically just going to have a beaker with ice in it and a hot plate and a thermometer. I have a stopwatch as well. So you're going to, I do the video obviously here for you, but I'll go through that part when we get to the video. You'll see what we're doing, just kind of fill it up. And then we are going to put our temperatures in, our beginning temperatures, and then we are going to record the temperatures at various times throughout this here. So we're going to record the temperature every 30 seconds. Now it's probably helpful for you to have the video to watch because you can kind of pause it to write down the temperature that you can see there. There's a couple things we need to do first though. We need to talk about key events that are going to happen as this goes on. And in these key events, we have 5 key events we want to watch out for. And we are going to record the time or time frame and temperature for which we observe these key events. All right? So please listen carefully to these. So the first one, and these will happen in this order, A through E. The first one is we'll observe how long is solid water in the beaker, and from what temperatures do we see solid water only in the beaker. And again, it'll probably be a time frame because it doesn't just happen like in an instant. And so you'll want to make sure that you also have a temperature frame as well. So time frame and temperature frame for both of these. I have a chart below that I'll show you here in a second. So again, it might be pretty quick though, because you'll have to watch in the very beginning. And the moment that you see water, liquid water form, you're going to stop that time. You're going to kind of make a note of that time. And that will be the starting time for this one. So the moment that liquid water first appears in the beaker, let's say that time is 2 minutes and 10 seconds, okay? That would mean that you had solid water in the beaker from 0 minutes to 2 minutes and 10 seconds, okay? And then the letter B here, liquid water first appearing in the beaker, that is just a one-time time, all right? So I don't need a frame for that one, okay? I only need time frames probably for A and C. So now I also want to record my temperature. So if I started out at 0.4, what temperature did it turn to liquid? What temperature was it at 210? Let's say it was 2.3, okay? So you would have both the temperature and the time ranges or frames for both for A. And then this would be 2.3. Okay. And then now letter C, again, these are just hypothetical. Only liquid exists in the beaker. So this is going to be when all the ice melts, right? Let's say that's at 9 minutes and 10 seconds, or 9 minutes and 3 seconds. So at 9:03, 9:03, that would technically be where all of the liquid exists in there. And this is actually going to stay this way for quite a while. So this will also be a time frame. So 9:03, there'll be liquid in the beaker until we get to letter D, which is where we see gaseous water first appear in the beaker, and basically steam. So the time that you start to see steam, then you have now introduced water vapor. So it's not only liquid that's in there anymore. So let's say this is like 15 minutes and 33 seconds. So you see steam at 15 minutes and 33 seconds. So again, steam and melting, those should be specific times, okay? And then also you would record your temperatures down here too. So let's say at 9:03, the temperature that all the solid ice was gone and just liquid was like 15.1 degrees, and then the point where gas first started to appear was like 78.1 degrees. So two time frames, a time frame and a temp frame for that one. And then 78.1 would be the temperature here. Kind of have weird columns. And then the last one, water begins boiling strongly throughout. Again, that would be just a single time. So where the time that you'll want to record is when the water really starts moving to the point where the surface is like bubbling and bubbling hard. Again, that'll just be a single time. So maybe that's at 22:09. Okay. And the temperature at that time is 87.4. Now, the temperatures will all be in degrees Celsius, so keep that in mind. And then we're going to continue timing for at least 4 minutes. All right. So I'm going to give you a minute to copy down this table. Basically, what that kind of table that I just drew as like a practice one for you. essentially is what you're going to put here. So pause the video, write an ice table, make sure that you give yourself space to write the event, the time frame, and then the temp, and then, or I guess this could be temp or temp frame. All right, so make sure that you get that down. And then the last thing that I'm going to do before you're going to go to the next video here, I have a couple problems with the video. The thermometers tend to shut off on me sometimes, and I wasn't paying attention. Bad, Maher. And so there are a few times in your chart that you're not going to have a reading from, all right? And that is at 17.5. This is, again, 17.30 seconds. Hopefully you know that. So we're not going to have a reading here, or at 18, or at 18 and a half. I notice it right before the 19-minute mark, so you should be able to record that. All right. And then the last part of it here too, the temp, it went off right, I think it was right before the 29 mark. So we'll count that. And we don't need to go past that anyways. The water will be boiling for quite a few minutes before that anyway, so it's not probably the biggest deal in the world if we have those. All right, so over here, this is going to be a time frame, so maybe I put in a temp frame, so maybe I put like a dash in here so I know that I'm going to need a number here, or a time and a time here, temperature here, temperature here. This one is just a, the second one here are just going to be single times or single temps. Only liquid exists in the beaker. Again, this is going to be a time frame, so in a temp frame. Gaseous water first appears. Again, that will be the same, just a single temperature. And water begins boiling throughout will also just be a single temp and time. All right. So the video I'm going to begin playing on here, but it'll actually be a separate video that you go and watch just because it's way too big. Or maybe I'll be able to actually forget about that. I would think I'll be able to kind of splice these together. So this is the beginning part of the video here. And you can see I have not added in the ice yet, so you can kind of just watch me do that. We're filling it up about halfway. So it's important to just kind of let the thermometer adjust to the temperature of the ice. And so we're going to wait until it goes down and kind of stops. So basically the lowest temperature. Remember, water freezes at 0 degrees Celsius. This won't go quite down to 0, but we'll get close. All right, so I believe this is going to be the temperature that we start with. So on your chart, at time 0, this should be 0.4. Again, all these are in degrees Celsius. This is right around 32 degrees Fahrenheit. Okay. Now, again, these times, 0.5 is 30 seconds, 1 minute, 1 minute, 30 seconds, okay? Excuse me. So, as we get going here. So when I start the timer, that's exactly when I turn the hot plate on. I'm going to turn it up to about a 6 or a 7. So you'll just wait till it gets to 30 seconds and then you'll record the temperature. You'll inevitably see, especially when the ice is melting and you have a cross between solid and liquid water, you're definitely going to see some like really kind of weird fluctuations in temperature. Like it's going to go up, then down, then up, then down. And that's just because you have cold ice mixing with water that's starting to warm. So No matter what, just pause the video at the 1 minute and 30-second marks or whatever, and just record down the temperature anyway. So I missed that one, but so back at 30 seconds right here. So the temperature is at 0.5. So you will record back in your chart at 30 seconds. It's 0.5. Okay. All right. So you can continue watching the video. I'll probably have it just go on right from here.